Now, we have two great speakers today. The first is Dan Guado, who's COO and Vice President of Engineering and Operations for Burlington Hydro. He's a professional engineer with a Bachelor of Science degree in Electrical Engineering from the University of Windsor and a Diploma in Electrical Electronics Engineering Technology from St. Clair College of Applied Arts and Sciences. Dan has spent 24 years in the electricity generation and distribution industry. He began his career with the thermal generation division of then Ontario Hydro and has subsequently worked with the distribution utility since 1989. He has experience in all areas of administration and operation for utilities and their affiliate companies, and has directed projects involving large enterprise IT implementations, electricity storage, renewable energy, and electric vehicle applications. As their Vice President of Engineering and Operations, Dan serves as the primary technical source for Burlington Hydro's Smart Grid City project. He's a member of the Association of Professional Engineers of Ontario, the Institute of Electrical and Electronics Engineers, the Society of Automotive Engineers, and the chair of the Energy Subcommittee for Implementation of Electric Mobility, Canada's EV Technology Roadmap. That's a mouthful. Jeff Cameron leads AGSI's Intelligent Networks practice, focusing on utility and communication-based enterprises. His work life includes 25 years' experience in utilities, information systems, as well as all levels of government. His experience with so many large and innovative projects has brought a wealth of value to all AGSI clients. Prior to joining AGSI a decade ago, Jeff was a manager at Capgemini, the team lead for the Geographical Information Solutions at Hydro One, one of North America's 10 largest electric utility organizations, and management with the Ontario government. Jeff has been directly involved in developing enterprise information system strategies for large and mid-sized organizations such as Hydro One, Canadian federal government, and Burlington Hydro, and has been instrumental in bringing AGSI's industry-leading, open, robust, and scalable Go 360 solution to these organizations. You can thank me for the little plug, Jeff. Jeff's involvement in delivering enterprise solutions includes developing AGSI's ability to handle very large volumes of complex utility asset, business, and sensor data, such as those generated by Smart Grid, and transforming them into efficient and usable formats for corporate end users. So, having said that, I will turn over command to Jeff and Dan.
Perfect.
And take it away, guys.
All right, thank you.
Okay, thanks. This is Dan speaking. This slide deck has a title that we used in another presentation that was quite well received, and so we didn't want to change anything because we thought we were going to change the template, but we thought that all the material that you're going to see here was appropriate then, and we got lots of feedback from people, and I think that's what led us to be here today doing this presentation. So hopefully you'll get something from this that you'll find helpful. Let's go through one more here. Okay, so just to put Burlington in perspective for some people, Burlington's at the west side of the Greater Toronto Area in this thing we call the Golden Horseshoe in Ontario, sort of at the west end of Lake Ontario. It's probably what you consider a large, medium-sized utility. So not quite what we call a large one, but it's certainly big enough. It's a full city. It's got all the issues of urban cities and some of the issues of rural activities, because we have the escarpment, the Niagara Escarpment cuts through our northern area. Okay, it's got about 60,000 customers here, 5,500 commercial and industrial, 32 substations. That's not a benefit. That for us, that's a bit of an issue sometimes. But we're an older utility, about 100 years old, and we were built, long before 27.6 became popular. That's our most sought after distribution voltage up here. We've got about 1,600 kilometers of low voltage distribution lines, and we operate with 93 to 95 employees. although that's a little late for us. What we wanted to do here is we wanted to bring together all of the networks that we had before revising our GIS, and many utilities here, like elsewhere, had GIS built up through the 90s and in the 2000s, predominantly separate systems from others. And what we tried to do was coordinate all of our database efforts around the GIS, the new GIS, and that includes SCADA and AMI and things that we had to have that we knew could provide benefits, but that we weren't taking full advantage of. And so what was very important to us was an open communication between our GIS and the other data systems that we use. So Burlington Hydro, like many utilities, was dealing with these issues of smart grid, and we decided to create this entity or identity that we call Grid Smart City, and it was an initiative to kind of get our arms around all things that are smart grid related and do something with that opportunity. We got 17 corporate partners that became interested in Grid Smart City and 10 utility partners. And together, we look for and pursue smart grid opportunities that may lead to spin-off businesses or may just be something that is a good fundamental thing in the evolution of utilities. And part of the goal here is for Burlington Hydro to become the kind of utility it will need to be to manage with a much more intelligent grid than it has today. You want to take, Jeff's going to take this slide?
Sure. Yeah. One thing that Burlington focused on was because of all the different initiatives around Smart Grid Ontario. I think 4.5 million meters went in. Ontario is legislated. We have a lot of renewables out on the network. And also just looking at things as an opportunity to integrate a lot of systems and streamline a lot of workflow processes at the utility and also do things like increase safety and better customer service. So one of the key things was to look at system integration, real-time integration, and all the different systems that they had legacy-wise that had to be integrated. So they had a legacy GIS system. Certainly smart meters was something that was being deployed and had been deployed. They have a SCADA system. They have some self-healing switches out in the network that communicate back to the control room. So there's a lot of different things out there that are going on and increasing, like the use of power line monitors this year and some other things. The other big issue was, tying to things like the customer information system, their internal ERPs, so for asset management, bill of materials, time reporting, all that kind of stuff. Engineering analysis, they have an engineering analysis package. And one of the things that they did, they had a study done by another consultant that basically looked at the environment and costs and looked at the need for a more open GIS consortium-based platform that had open standards. Certainly the world of smart grid has gone open standards with things like the Common Information Model, IEC standards for communicating, even to your SCADA system. So it just sort of fit that bill. And that produces a much more plug-and-play environment. So, and the other thing, too, was by leveraging more common resources. In this case, they use Oracle as the back-end for the GIS. They could use a lot of their existing a lot of their existing IT staff for management of the solution that was being implemented.
So we had this issue with, we wanted to operate in real time. We needed the bidirectional communication to work in real time. So, an example of that, which, we'll probably talk about a little bit later on in one of the slides from our control room, was this thing we call pinning. Forever, our people have pinned on a paper map, so that indicates a switch is open for work protection or some other purpose. And we wanted to be able to do that in real time, so it not only happens in the control room, but it's seen in the field. And vice versa, they can do an action in the field that can be seen in the control room. So this had to be truly real-time performance, and that was the driver behind all the communication that we were trying to build into this. And the other big component was the data. We knew that the smart meter data was, many orders of magnitude higher than the meter data that we had in the past, but that it also meant we could tie it in and do things. And again, later in the presentation, you'll see how we tie smart meter data together in real time or at any time in the past to show the loading on a transformer. So we don't have transformer meter on that transformer, but we can infer the loading from the smart meter data that's timestamped.
I'll give a little history on what Burlington had coming in before they upgraded the GIS and implemented the system. So I think back about 2008, 2009, Burlington Hydro was using a legacy cable CAD environment. I don't even think that product supported anymore. So they needed to do something to get their data into a connected model, and a clean connected model, one that can be validated and verified. And the old database was only a parent-child relationship. It wasn't true electrical connectivity. So that was the legacy system that they had. They have DAFRON here as their ERP, so that does billing, work orders, manages asset information around transformers, time reporting, all that kind of stuff. On the engineering analysis side, they have DES, and I think you also have SIME as well, so just for different modules for doing different things. So how do you tie that in and feed those systems with accurate information? There was also data that had been collected in the field for asset condition assessment data. It was kind of a one-time thing, so obviously they want to go out and start maintaining that. There is in Ontario a regulatory requirement to inspect the entire network every 3 years. So tying in that data and then keeping that up to date. They have a SCADA system. And then there's lots of things going around with smart grid in Ontario. It's a very kind of unique place. There's a lot of emphasis by the government to do a whole number of things. So obviously the smart meters one, EV charging stations, so electric vehicles, a lot of renewable energy going on. I'm not sure how many connections there are and pending, but there's a lot. And how do you manage those as well? So now we have electric generation happening on the distribution system downstream of the breaker of a station, which we're not used to handling from before, and of all different sizes of generators. So what they did is created an enterprise data warehouse. It sits in Oracle Spatial, and very robust, where they can actually talk to their legacy systems in real time. And the idea is that they wanted to be able to view and share across the organization everything about the system. So what the normal state is today, what the planned state is tomorrow, using transactioning in the database to be able to do your short and long-term design work, subdivision work, posting of that work, and give visibility of that to people. And then on the other end, providing applications, which is what they've done here through Go 360, that does everything from stuff in the control room, mobile applications, applications to the executive, applications to their asset managers, where they can actually query and report and plan their work. So, and we'll look at some of this stuff live. We thought one of the things we like this presentation is we can show some fairly current stuff like storm information from Hurricane Sandy and stuff. So we'll be looking at that soon and how they actually use the application. But what they ended up doing is quite quickly implementing the solution, and you can see all the different touch points. So if we're thinking about the GIS, it's this warehouse in the middle, and it's either taking feeds or even dispatching or sharing information out to other solutions. So we can see bidirectional arrows or one-way arrows. So the SCADA system for now is taking information for the SCADA system. When Dan was talking about pinning, breakers in the substations open up and you can actually see that in the map and what's going on. They have a design system called Spatial Power, so that's where they're actually designing the network. They can share the plan subdivision work or whatever plan changes. You post your changes through there. Their DAFRON, their customer information, ERP data is shared through here, and there are bidirectional links back and forth. For DROMI, what they're doing is engineering analysis, load flow, short circuit analysis, that kind of stuff, and passing information back and forth between the two models. So DROMI has its own model, and they're reading it out of the GIS model and sharing data back and forth. Their smart meters is coming from a system called, what's your smart meter? Elster, there we go. Elster, and they also have some self-healing switches from S&C Electric called IntelliTeam, and IntelliTeam has the communications that can go back and forth towards those smart switches. And then, of course, applications that keep growing or how they're using this. So there is an enterprise viewer, but it can look at the data, query the data, analyze the data, how many poles that I have, what condition are they in, that kind of stuff. Then they have applications in the control room called Live Ops, where they're actually doing the pinning, they're seeing the outages, they're calculating their outage reports, they're dispatching work, all that kind of stuff. They have a cable location application, a mobile asset inspection application, executive dashboards, and a smattering of other stuff that we'll look at. So.
Sorry to interrupt real quick. Are we supposed to be seeing images on the actual slides? Because we're seeing the title, like right now, Integrated and Accessible Solutions, but is there supposed to be images?
Yes. You can't see any pictures here?
No, those are not coming across on at least on my live meeting.
Anybody else having that trouble?
Nope, I'm able to see the images. This is Michael Charter with Consumers Energy.
It might be your potential bandwidth.
I'm having the same issue as well as Kevin.
Same issue as well.
I can't even get into the live office.
Oh.
So it's not even taking me to a place that allows me to join.
Okay, I'm seeing the images. Let's just try and reloading them again.
Now it's coming across from us.
Yep, see him now.
Oh, okay. Sorry about that. People, I didn't know.
Yeah.
He must have just thought we had this all memorized.
As far as the person who couldn't get on at all.
It's Jim Horseman, John.
Okay, Jim. When you click the first link in your meeting notice, it should have brought up should have brought up the website, and there'll be a bar that shows up at the bottom, and it'll I forgot what it says, but you've got to click on the appropriate button. Did that happen?
Yeah. Hang on. Maybe I got to scroll down. There. Okay. I think. Okay. 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 I'm good.
Okay, you good? All right. If that happens, if the issue with the images happens again, we'll just back up and reload them. I don't know what kind of voodoo is going on, but that seems to be the solution.
Okay. So.
So speak up if it happens again.
Okay. Cool. So on this screen, it's just a screenshot, but I think one of the ideas is when we're talking about that there's just one central repository for the data that everything either feeds into or accesses. That's exactly how the system's set up. So, and we can see how they're using it in different applications. Just a high-level example. In the middle, they have their design tool. You can see a couple of feeders being traced high-level with orthophoto integration. Actually, it's pretty neat here. They have 7-centimeter orthophoto in this city. So that gets loaded in the application. You can see just about everything you can imagine. In the top right-hand corner, what we're actually looking at is color-coded transformers by overloading. So you can see that a lot of red dots. That was a very hot day in July. But that's information that's coming from the smart meters through the network connectivity, loading to the transformer, knowing the rating of the transformer, and displaying and alerting where the overloading is happening in the city, and which is pretty neat. As opposed to the bottom right-hand corner, which is a mobile app inspection application. So the guys are in the field, they're inspecting the health of the asset, reporting on that, taking photos. If there's an emergency and you take you identify that and you take a photo, it immediately goes back to the control room. They can do something about it. A log does go to the asset manager on all the stuff that might need maintaining, so they can then go look at it the next day and start planning their budget for 2014, as an example. The ability to actually have dashboards around all your information, whatever happens to be And even for the executive in the top left-hand corner, there's a summary executive dashboard for just about everything you can think of in the company. Not a lot of maps, but a lot of charts and graphs and alerts and the type of things that the CFO and the president and the COO is looking for on a daily basis. So, just a little bit of their network setup, because there is a mobile environment, there is a SCADA system, there's a number of firewalls and DMZs, so the system's actually set up to be highly secure, both not just at the database level, but fit within that environment, so data can come through the DMZ SAM mobile, or if it's coming through the SCADA system without, directly worrying about a virus or something like that, it can actually, it's set up to actually check the data before it transacts between the other systems, as an example.
Hey, excuse me, this is Greg Shipp at Alabama Power. We have lost the graphics now. We had them before, but they're gone now.
Yes, refresh.
Okay, yeah, got them now.
Okay.
Thank you.
And you can see the different environments. So just, high-level IT. I'm not the IT architect, but between Burlington's IT staff and their security people and ours, they've come up with an environment to make sure that the data is coming through is secure and that the back-end systems, especially when they're using it for outage management or SCADA, are absolutely secure.
John, Dan here. Since refresh is so quick, why don't you just do that every slide?
There we go. So the one thing about their environment is it's very web-enabled, if that makes sense, so they can get the data in the GIS out to the people that need it in very easy-to-use forms. And the nice thing about the system is as they build, there's actually a self-configuration engine now, so they can build applications that can work on their corporate environment, which happens to be Windows. But if you're at home, you can look at it on your iPad, you can look at it on your Android phone, or we're going to test it out in the new BlackBerry 10 because Dan just went and got one. But I know it works fine on a Playbook, as an example. So making sure that when you build an application once, it can go to the users in an environment that they're comfortable with. The other thing, too, just because of the security engine, people get different views of the data that they're required to see. And it's not just views, it's also editing. So somebody might, in the field, pick up a pole and move it, or go out and put in a temporary fix, and that'll come back to the control room. Or they'll go out and collect asset information. So it really depends what they're doing, but there's full functional editing. So what they've done is said, okay, here's the design, the typical traditional, we got the design, the posting, but we also got the workflow where people in the field are actually doing their work, and that work can come in any number of ways. And we're actually moving, or Burlington's moving the next step where stuff that gets energized, work that's completed during an outage is actually being posted by the people in the control room, and that just reflects back in the corporate system. So changing a bit how we traditionally do the work, because the people that actually are responsible for validating the data will now be the guys responsible for posting the changes that actually happen, and a lot of that's going to come through the control room. So. Just going to another slide, I want to refresh that again just to make sure. So one of the things that some of the stuff we're going to look at in a few minutes, we're going to look at how they've automated their old map paper-based pinning and turned it into a live application in the control room. And it's not just pinning, it's also your work protection tagging, so your work protection code. It also includes integration to SCADA. There's a future integration to ICCP for the transmission that's been set up. So the modeled in the GIS, there's a full model distribution and transmission stations. And actually, for the engineering analysis, the source in DES right now is coming from the transmission station. So that they've got a full model that goes all the way back up. They've gone in and used or developed a solution called asset inspection to go out and do their pole testing, transformer details, inspect every asset, health the asset. We'll look at that. Automating their outage statistics, OMS, full field force automation, and some pretty cool analytics now with the smart meter data. So we'll take a look at that as well. So, beginning hits the arrow. So you might want to refresh that one. So actually in the control room, they used to have a big wall board for pinning. Now they have a big 4-panel screen that's interactive. It works like a giant iPad. That's just an example where they actually go in and they pin, they tag, or the SCADA assistant comes back and says these breakers opened up. And you can go to different windows so you can look at schematics or trees, and it's real time, which I think is one of the key things that we're going to see. There's another one if you want to refresh that. So here's just an example where they actually will go in and do what they traditionally did as pinning. It's just now electronic pinning. So they'll open a breaker, open a switch, add your work protection tags, generally before you open a breaker or switch. Yes. Record all that information, report all that information, even play back that information. And one of the big key things now is it's not just manual operator placement, but as I mentioned, the SCADA system and the smart switches will actually pin the map as well, because they're actually themselves opening and closing devices in the field. And the other integration is with the AMI reads. So where are the outages? What do they look like? How do you interpret them? And we'll take some examples from Hurricane Sandy, so you'll see what that looked like as the storm went on through the night, which is pretty neat. So here's an example of that pin application with the schematic view. That's actually Burlington Transformer Station in the middle. Is that a 230 kVTS? Yes. So it's 230 kVTS. You can see the lines coming in and out down the station level. You can also take that schematic and build a tree out of it. So you can see the logical connection of the tree. It's always real time. So for example, if any of these transformers were out or any of the equipment from the AMI showing it's out, they'll turn gray, and you can actually follow up the tree exactly where the problem is on the network, which is pretty neat. Also using those views together. So if you're going to be looking at the geographic, it helps the operator to look at the schematic. So working together, in this case, even when you click on a piece of equipment, seeing what the normal state and the current state of that switch is and what it should be. So helping the operators just bring all that information together in a way that works for them. And again, there's a tree generated from there. That's actually a case there, I don't know if you can see on the screen, where the transformers are grayed out. So that would mean that those transformers actually don't have power, and you can trace it back up to this common fuse right here, which is very useful to the operator, just generates on the fly and to get the information that they need. SCADA integration, so there's a substation, we got some breakers and reclosers and step-down transformers. And there's a pin. So that would be a pin, again, opened by a SCADA event. The operator can add information, like we had a lot of supply from Hydro 1. They do have their pick list and types of detail. And then it records a log, so you can look at existing events on the network. You can look at historical events on the network. And there is a playback where you can take a storm and just sort of play back over time what you did in terms of restoration. So what were all those things that we did on July 12, 2011 that worked so well when we restored that, did the restoration for the storm. In their, typical GIS thing, the operator can hover over it and get the details that they need. Or in the field, they can see that as well. So it's not just the operator, it's the people in the field seeing the same information as they need in real time. Here's a transformer station, so Burlington TS, you can see the details. Again, it's connected, it's a schematic view, and if you have an ICCP event from Hydro 1, it will again tag it. So that's what we're working on now, is getting that link from them and getting the information that they need. And zoomed out, you can see that on the map. They've also integrated things like Google Street View. So again, just handy tools for people in the field, people in operations. They have their own photos. In this case, though, you can click on the map and see what's at that corner or intersection that's been captured in Street View. So it's always good not just to see equipment that's there, because they do have some of their own photos, but sometimes it's nice to look around and see if there's obstructions or other things. What does it look like before you get there? The other is reporting. So everything that's in the system can be reported on, and there's actually a little self-configuration engine where they can build their own reports, because you know with reporting, you can ask somebody to build your report, and 5 minutes later you want to know about something else. So you can build your own reports. So this is just an example of 10 or 20 reports that they've built for the pinning application. So, or in just a little environment. So you got a little window, you pick your report, you can pick your details about the report. In this case, let's look at all the actively open points on the network, and you can map it, or you can generate a report, you can export it. You can do it by time, you can do it by history, you can do it by safety tags, you can do it on anything you can think of. You just generate your own reports and get your own information. It's kind of neat. So how do they use it? Well, here's an example of a real life example. We had Hurricane Sandy not that long ago come blowing through in October, and it certainly had a big effect in Ontario. And I can show you some visualization of the time-based outages that were occurring at night. So the system will create something called a heat map. So this is at 10 o'clock in the evening on October 29th.
Hey, Jeff. Let me just, are we still having that issue with the images not loading? Because this is going to be kind of funky if I keep reloading each of these. Why don't we try just going through them straight, Jeff? And if I have to, I'll start reloading them.
Okay.
So raise your hand or yell if you're not seeing the changes.
Okay. Because you'll see a change here in a minute. This is 10 o'clock at night. You can see the small outage. I'm clicking the arrow now for 11. Can you see any change? That's 11 o'clock. Can you see the image?
I can see it, yes.
Okay. Okay, so that's 11. That's midnight. So we can see that the outages are more widespread. So what's kind of neat about this system is it'll take all that information. There's 65,000 meters. Some of these were up to about 10,000 meters reporting back. And if you're looking at the citywide, we can here, you can see that extent of the outages. 1 in the morning, not as bad. 2 in the morning, starting to spread again. 3 in the morning, more down in the south. 4 in the morning, right across the city again. 5 in the morning. It's pretty neat looking at all what was going on. There's a lot of wind and rain that night. So there's 7 a.m., 8 a.m., 9, and then finally it got pretty good. And so there's just a little bit of a zoom in at a particular time at night where you can see that there was a density of outages around these particular distribution stations, so more likely it was a whole feeder. But the system's smart enough to go in and look at the information. There's a good example where we have a bunch of open points. There was a whole feeder that was out, but these people would be calling to complain that their power's out. You can see that the meters are not on because they have the outage flag coming from the system. But these little guys here in the corner, they have power just fine during that particular outage. So very interesting when you start looking at neighborhood level.
Just before you leave that one, so we sort of envision this as future customer service view. So if they're talking to a customer, they want to see a simplistic view, maybe not even have the schematic there, but just the shading, so they know where that customer is based on the address or the phone number, and they can tell that customer very quickly, yeah, they're in the outage area, or this is how much time it'll take to restore. So they don't have this tool right now, and as we got into this, the schematic tool sort of developed for the control room application, and we tried to simplify the tool a little bit for the CS people.
Here's an example where we had a little subdivision out, and through the network connectivity, tracing back to the common, in this case it was a fuse actually that probably blew during the storm. So again, helping in restoration. How many customers are out? So there's 300 customers on this feeder. There's 20 customers downstream of this fuse, or there's individual customers like we're going to see here that were and there's that tree diagram from there. So you can see the transformers and that fuse that was affected by that generates on the fly. In an example like this, where there's obviously individual wind damage, so probably a tree blew down during the hurricane on the service connection. But it really helps in prioritizing work and also studying after the fact what the problem was when you're doing your outage statistics and your outage reporting. And I think eventually as we get more data, and you'll see in a minute with the analytics, looking at the health of the network and health of feeders and loading on feeders. So that's an example of looking at the outage flags from the MI system. But we can also look at, there's another example where we can change the look and feel of the shade in case you wanted to make that public so it wasn't so personal thing. And then using the same smart meter information to do other things, like looking at transformer loading, asset health, loss of life on equipment, and playing back what happens during the hottest day of the year, the coldest day of the year, or a storm. So we'll look at that here. There's an example of July 17th, 2012, and that's overloading on transformers derived directly from the AMI consumption information. So taking that network connectivity and loading that back up to the transformer.
Just before you leave that, Jeff.
Yeah.
So one of the reasons we showed this area is this is an old area of the city. We know that infill has happened here, and people have added to the load that they started with. It was built quite some time ago. And I think it's 120%, isn't it, over a transformer rating that they turn red. So you can see, even though this is for a short time, not all those transformers are in trouble, but some of them might be, and this is the kind of thing that we wanted to know more about that we couldn't see before because we didn't have the smart meter data connected through. And one other point on this, it became clear very early in this process that traceability of the system was the absolute most important feature that we needed. It feeds into all the applications, including the engineering analysis tool. But for this kind of an application, it's vital to have the circuit completely traceable so that we can get that meter data, placed in the right transformers.
Here's an example of just a heat map shade looking at particular transformers. We'll drill down and we'll show you what we mean by that connectivity. So here's a neighborhood. You can see where the hot transformers are.
How current are your AMI reads that you're using for that? How often do you get them?
2012, but the AMI reads are completely current, like they're real time.
So you're getting them in real time to do this, not 6 hours later or something like that.
No, real time.
Yeah. Okay.
They upgraded their concentrators here from Elster, so they're on the newer energy access system to get the real-time data. So, it may be minutes, but it's not 6 hours. I did another project at Toronto Hydro, and it was once a day, and that's not unusual for a lot of smart meter implementations.
Yeah, unfortunately, that's where we are right now. So we gotta fix that.
Yeah. And there's an example. I don't think you can see on the screen, but I just highlighted the orange line. That was from a network trace, just so you can see that those individual customers are feeding up to that transformer. It will give you information in a report as well. So that's just a little export. There's a whole reporting analytic engine behind this where that particular transformer is a 15 kVA, and I remember when Dan and I were looking at that, Dan yelled across the hall to Peter German, who's one of the engineers, going, "What? Is that real?" And it turns out it was. It was an old 60-amp neighborhood, I think.
Mm-hmm. Yeah.
So there we go. So that gives you information and insights on what you can do. Sometimes it's just swapping out a transformer. Other times it may be, hey, we're just getting overloaded in a particular area. So. The other thing is getting into more analytics, graphing and charting the reads. So I'll give you an example here where we will actually drill down to a particular transformer. There it is there. We'll actually go in and look at the 15-minute interval reads. So if you can see that chart, these are 15-minute interval reads. They're color-coded by loading, so if it's gray, it's less than 25%. If it's blue, it's 25 to 50. Yellow gets up to 100, pink gets to 110, and everything over 120 goes red. And you can see we have a lot, on this particular day, a lot of high reads together, which means the transformer is not getting a chance to actually cool down. And we can even see when an outage an outage flag came through. So this O, I think the Elster system stands for outage, R stands for restoration, and T stands for time reset on the concentrator and the meter. So looking at this data, and some more information. So this is a summary.
Did everybody see those bills? I guess so. Okay. Good.
Okay. So this is looking at the details and analyzing the data in the back end. This transformer was overloaded 64% of the day, which is pretty high. It had one outage count for a total of 15 minutes. But what was interesting is it had a loss of life calculation factor of 1.11% for that day, which isn't good. So it was one of the worst performing transformers in the territory, but obviously there's a problem. We can also look at that for a week. So it also happened to be the hottest week of the year, so it was actually overloaded for the entire week 74% of the time, which is pretty high. Had 2 outage counts, and for the week, because it wasn't getting a chance to cool down, it lost 6.7% of its life. So that really is useful when you start going into things like looking at asset replacement, using that information to use for planning, use for work orders. Maybe we should go out and replace this out, all sorts of things.
Oh, yeah, believe me, there was a time when I thought I was better off not knowing some of this, but now that we do, I think we can at least take action on things that we didn't know existed. And it's due to the fact that we did roll out smart meters across the whole province, but of course across the whole city of Burlington, and we can now utilize that data, whereas we've never had that in the past. So it's been quite helpful that way.
Just a question: when you did your loss of life calculation,
yes,
is that just an industry standard way that you did your loss of life calculation, or did you have a particular one that you used for yourself?
I'll go back up. It was actually, we did another project with Toronto Hydro, and they asked us to use, and if I can read it here, it's not on that report. It's IEEE, and if I can fire my computer, I can tell you the actual standard they used. I could send that to you if you want to know. I can't see it here on this report, but we've used one that they recommended we use.
Jeff can send it to me, and I'll send it out to the whole group.
That sounds good. I think one of the things that's coming up, and Dan and I have been talking about that, we're starting there's a pretty big smart grid project starting in Ontario. We're working with Siemens, and we're actually going to be putting sensors on the transformers and getting more information like oil temperature and things like that, and running that against manufacturer data and trying to come up with a much more accurate calculation. But given where we were with the meter data, and there was no meters on the transformers or the sensors, it was sort of the industry standard one we used. I'm not an engineer, so I don't know how they came up with the formula, but that was the one we used from another project. There you go. The other is playback. So just trying to simulate it. Actually, there is a little playback. You can zip through it. It'll play overloading outages, all sorts of things you want to see. So this is, again, July 17th, using the same day. Here's a neighborhood. And we can see the transformers color-coded by their loading. So if I go to 5:45 in the morning, there's actually a temporary outage event. So everything went gray. We can see that there wasn't any reads. By 5 p.m. again, everything was good, but we had some overloading happening. And at midnight, it looked like that again. So still a couple of hot transformers because people are trying to sleep. We get a lot of humidity here in Ontario, unfortunately. So if you run your air conditioner, so you can go to sleep, and then hopefully it turns off. So, but that's the same type of thing they use for everything. It's not just loading information. You can integrate that with pinning, outages, just about anything you can think of, you can play back, which is very, very useful and something that's
Yeah, what Jeff's got on the slide right now is we used to do this process with paper. I mean, people would go out, record things about the assets, and then bring them back, and that would be re-entered. And now we can do this electronically and in real time, and we in fact have to do, as Jeff mentioned earlier, we have to do our whole system for the Ontario Energy Board every 3 years. So that means we do a third of the system a year. So it's become a more intense process, and this is a way of automating the process so that we can deploy fewer people to do it. If they can go through the system very quickly, the tablet points them, once they're finished the switch gear, for example, it points them to the next switch gear in a logical sequence along the road network, and they can record data and do the whole system very quick. In fact, we used, I think, predominantly 2 people only to do a third of our system the first time through. So yeah, it worked quite well.
Yeah. And the nice thing about it, and maybe I come back to the start where we have this central repository, it just sits in a big old Oracle database, is that the data you collect on the asset condition from your manual inspection can be correlated with the smart meter information or the operational data to give you more insights into the health of that asset. So it may not just be starting to get overloaded or overloaded, it may also show that it's got some hot elbows or maybe it has other issues with it that you can really start using your planning to go, hey, wait a minute, we've got some real things sticking out here, and if you can identify those and replace those, you help your outage statistics. You have more evidence to go to the regulator to get your rate base and your rate hearing and your monies for the next year. So it's just better information that they can start correlating, which is pretty important. This is the way it looks in the office. When people are actually out collecting and updating, they actually have a dashboard that's running all the time. So you can query anything you want out of the system. So what have I inspected, or in this case, what hasn't been inspected is in red, what has been inspected and that's good is in green, things that like cubicles that need cleaning are in yellow, things that need repair are in blue. And you can report on just about anything you want out of the system again because it's just in the database. So in this case, and they're automated notifications. So anytime something happens in Go 360, you can set up who and what you want to be notified. So it could be alarms in the control room, or in this case, if they find something in the field that's an anomaly or not good, there's automated emails. You get the picture, you get the details, who collected it, what's wrong with it. All can come to your, for example, your BlackBerry or iPhone. You can report on what you've actually done. So I want to know, what did I inspect? What did I repair? So getting your accomplishment and asset condition reports. Looking at individual tasks. So what did I do this particular thing if I had to go fix it? So just ways of getting at the data. And you can export it anywhere you want. If you want to bring it up to a report, if you want an Excel, you want an Access, however you want it. It's totally up to the customer. And I think that the key thing is really bringing all that information together. So it's not, there's no copying or pasting of data really around the company whatsoever. It's running out of a single repository now. And as they're building up all the information, they're just getting better analytics and sharing that information amongst the other systems that require it, whether it be their ERP or other things, and getting at the data as they need it. I think one of the key things is, this is sort of some of the accomplishments summarized here. Some of the things that they're looking at for this year or next year, and we're also cooperating with a couple of other pilots as well that are going on in Ontario. So one of the big ones is there's a smart grid project going on, and we're being asked that all the messaging to and from the DMS we're being asked to integrate to uses SIM-compliant messaging, so IEC. Even the data model, the way we would share data, or we're going to share data with the DMS system, is going to be a SIM-compliant network connectivity model, so in XML format. So it actually goes into that DMS, it calculates and then spits back to this system in a SIM-compliant message what to do on the network or what's happening on the network, which is pretty neat. Asset analytics, there's a transformer monitoring application going on next door. So the way we're calculating the load on a transformer, it'd always be nice to know what the actual load going through the transformer is. Ontario has been known to have a few grow houses around, so we might see some interesting losses as an example, what's happening. There's a power line monitoring project going on, so we're looking at power quality, power factor, that kind of thing. Getting into advanced asset analytic models. So one of the key things is raising work orders from real-time information coming in is another one. So setting up your KPIs, so the key performance indicators on your assets, getting that information, and then literally leveraging the smart grid system to tell you in real time what's happening to that asset or those assets, which is neat. Real-time mobile dispatch. There is real-time access now, so I could probably take that one off. It's an old slide. And then doing some more integration. Dan and I, when Dan was at a previous utility, we integrated a battery storage project, and I think you're working on one of those.
Yeah, we know some things are coming to our grid that were never there before, but some of them are already here, like distributed renewable generation. EVs are showing up in our city, as in many cities, and stationary storage. Different projects are being discussed. We're talking about a few, and this thing I call flexible loads and microgrids will also be part of our grid. So the first step in all of this is, in understanding it, is, well, where are they? So we're going to use our GIS to track them. We've created symbols for some of them already, and we're tracking them. I think at one time we had 248 applications for renewable generation just in this city. Now, not all of those are going to go forward, but they ranged in size from 2 kilowatt systems to 300 kilowatt systems. And so we have to know where they are, and eventually we're going to need to know how to manage the grid with those things connected to the grid. And we're trying to look ahead and say, okay, what do we need to do now to make that possible in the future? And one of the things we need to do, of course, is to track where they are.
Yeah. So, and I think with the DMS project coming up, it'll give us some lessons learned on how to actually manage that in real time. Because we've been watching a few DMS projects going around in North America. I'm just not sure I've actually really seen the live integration to the generators and doing the system optimization that needs to be really looked at. And I know that's the mandate that we've been given, so I guess we'll find out. It'll be pretty interesting. That's supposed to start in April. So.
Yeah, Jeff, Dan, I'm involved in some of that, and I can plug you into that offline.
That'd be great.
Okay.
That'd be great. So, and that was really our presentation, sort of overview of where Burlington's at, how they got there, where they came from, and some of the interesting things that are working on. There's more, but it's kind of hard to show everything.
Yeah, and one last comment I guess I'd make is we did not know or realize how many errors we had put into our old GIS over 10 years or longer until we decided to try and clean it all up. And I think that's a pretty common problem. I've heard that from other utilities. And it's a big effort. You have to use people, and it takes a lot of time, and you think it's never going to end. But it does end, and it's well worth it. And some of the larger utilities in Ontario, quite surprising to me, have seen our presentations or come to us and said, how do you do this certain thing? And we said, well, you need, first of all, you need connectivity, and you need to be able to do traces to confirm, what you're putting onto the map fits and works, and everything, every piece is connected, including the meter. So it was a big, monumental, grueling thing, but we did it, and we did a lot of it with, co-op students and young people that were very familiar with technology and could work very quickly, and they were a big help to us. We had to train them up to understand, what distribution things were and how they work together. But after that, boy, it really made a big difference. And now that we've got it, all the way through, we knew that was one of the fundamental things we just had to clean up. And it's surprising how many you'll find when you get into it. But and it can seem daunting, but I'm telling you, it can be done, and it's worth it. So,
one of the questions along that note, when you saw the transformer overload, did it?
Can I just break in a second before we open up the questions?
Sure.
We're coming to the top of the hour, and some people are going to drop off. I just want to point out that in the upper right there's an icon that looks like 3 documents. You can click on that and download a PDF of this. And I will be posting this to the smartgrid.epri.com site and sending out the link to everybody so you can actually look at the webcast. So having said that, let's open it up for questions, and you know, we'll kind of ride this out, and if people have to drop off, that's cool.
So the question I was asking was, when you saw the transformer overloads, were those indication of true overloads, or did you end up seeing some data integrity issues between your customer and transformer relationship?
Good question. You have to keep in mind the red color does not indicate temperature necessarily. So what we're trying to do is give an indication of what the smart meter data integrated together shows us the loading is on that transformer. And we're still learning throughout this process. This is the first time we've had this kind of information available to us. I think it's safe to say that what it tells us is we should look further at some of the transformers. So, in other words, are we actually combining that data in a way that gives us an accurate indication of something on the transformer to be concerned about? Or do we need to, once we see that kind of an indication, do we need to go and put a transformer meter on that unit to see what it's doing, you know, measure it directly? So I think it's a little early for us to draw conclusions from what we're seeing there. We do know the smart meter data is telling us, and we believe it. We don't want to fly to the ground because we don't believe the instruments, but we definitely know that there's a problem. Those transformers are overloaded, and we know the area. Some of the people here are very familiar with the area and say, yeah, it's grown over time. There's been infill, and every home has now got a pool and a hot tub, and you know, they've upped the service from 60 amps to 200 amps, and so we know that we have some issues there, but that's not a temperature indication. So we don't think there's anything imminently happening. We just think we've got to go and look further. And the first indication we really had of that was when we combined the smart meter data.
Yeah, I think for an example like this was the hottest day of the year, and there's probably in Ontario, I don't know, 2 or 3 weeks where it's pretty bad, and then it's kind of normal after that. You don't see a lot of overloading, but you can see some. It is interesting if you look at different days, even in November, and you still got one transformer that seems to be overloaded. You know, there's something else happening. I think with this other project, with the transformer monitoring as well, if we do indicate something like a grow house as an example, that'll be real interesting to see what the effect's been on the equipment and what they can identify. So that's coming up too, which will be kind of neat.
Okay, any other questions? Okay, well, I want to thank our speakers. This was fantastic.
Hey, John.
Really impressed with all the capabilities and all the data streams that are collected in one place. And you know, the pitch about good GIS data was right up my alley, so I'm happy about that too.
Yeah.
So with all that said, we'll end the webcast. I'm probably going to be, like I said, I'll be posting everything and sending out all the links. And once again, I want to thank Dan and Jeff.
Hey, John.
Yep.
Hey, John. This is Greg Ship at Alabama Power. I've got one more quick question if you can hang on for a second.
Sure, Greg.
It was mentioned that your AMI meter was real time. I think on our AMI data we get like 15-minute updates. Two questions really. On your outages, are you monitoring momentary outages? And also, are you having to ping the meter to get this information? And if you are, how long does it take to get that information back in?
Okay. I guess there's two parts to that. One on the SCADA side, yes, we do pick up the momentary outages from the SCADA system, and it's just always rolling through. On the AMI system, the Elster system, the new collectors that put up, they actually push out to us the flag, so we're waiting for it. We haven't got to the point yet just because it's brand new and we haven't got that stage of the project. We were just getting that, making sure we had that first. Will be the pinging of the meters, so going the other way. So I will be able to tell you that once we do that next step with them. So I'm just getting those messages from them now on how to formulate them. But that's a good question, and maybe we should go back and look, because I could probably, all those flags are timestamps. I do know, for example, here's a good example, that they have an issue with how many meters start reporting back that will start to clog their system. Our system's a little smarter than that, where we know we start getting a bunch of meters reporting in on the same feeder, as an example. We will correlate that with, say, a breaker event or something else, and start deducing if the feeder's down or if it's somewhere on the network. Because we do recognize that they're pretty good if, 100 flags go out or 200 flags go out. They're not so good if 3,000 meters go out and the same collectors are trying to bring those back. So there's still some technical challenges there with that concentrator.
Okay, thank you very much.
Yeah, no problem.
Okay, our next webcast is going to be with Cooper Union Co-op, who's deploying GIS in the field. And then if Greg Ship's still on the line, I'd love it if you could talk to us about some data cleanup efforts that you're doing in a couple of months. So I'm going to put the arm on you for that, Greg.
Yeah, I'm still here. I'm sure that between me and some others on our team, we can do that for you. Not a problem.
That's some fascinating work. So any other questions? Going once, twice? Okay, thank you, everybody.
John, thanks for having us.
Thank you.
Bye for now.